Well, shall we get started? Yes.
Hi,
So first, okay. Go on. Yeah.
Go ahead.
You can go ahead. You can go ahead.
Okay. Hi, Rocky Working Group. Welcome to the second meeting. We are about to start, and we'll start with protocol-assisted protocol that has been moved from first meeting to the second. So if presenter could get ready, I think it's going to be Robin, right?
I believe it's Shuang.
Okay.
Okay. Hello, everyone. My name is Shuanglong from Huawei. Okay. This topic, today I will introduce the topic is the protocol-assisted protocol. Okay, next, please. Okay, first I will introduce why require east and west assisted protocol function. Here at least two reasons. First is we know the existing the north and the south method has some challenges. The one is the large amount of data to be exported. We know that on the network we have the many devices and protocols and data like this. And another challenge is the high performance requirements on the controller or MS. If the controller or MS to complete all these tasks. Yeah, this is the two challenges. And another is the reason is the user habits. Now the local configuration and the maintenance is more convenient. And if the user use the MS on the controller, and then they have to take time to adopt it. Yeah. Now for another controller protocol, like for example the SVT and the BGP, in fact has some the existing method, for example the pass error and the result error and the BGP notification message like this. Next slide, please. While a common assisted protocol is needed, we know that if the protocol is failed, it cannot advise any information to the neighbor. Yeah, this is mainly the reason. Another is the existing control protocol is restricted. For example, if the more maintenance the information is introduced, it may have much the impact. For example, the BGP and SVP. We know the BGP, if a BGP extends the path attribute in update package, then when the device received the update package message, it have to the how to deal with the attribute, how to save and how to search in and how to compare and how to package like this. So I think it has the big impact. And another protocol is SVP. SVP extends the course code for path setup the features. But SVP protocol we know only has two ULANs are available. So this is the two controller protocol. Okay. So if a common protocol is used, I think it's better to define and advise the related information. Next slide, please. Here I list the two troubleshooting use cases. First one is BP routing oscillation. If a device want to know which guy is the oscillation the source, it will send a message. I use the oscillation source to his neighbor. If the neighbor received the message, he can reply a message, yes or not. If not, then the neighbor can continue to save the message to other neighbor. Okay, until the someone replies with the oscillation source. Yeah, this is the first use case. And another is RPT, the setup failing. If the failing device can send a notification message to the ingress device. For example, a link feature happens here. Okay, next slide, please. I introduced the PEP protocol. We know the protocol, the PEP, is designed for device to exchange protocol-related information between each other, and separates the routing and the non-routing data. I think the PEP has some of the merits. For example, the facilitates the automatic troubleshooting and not impacted on the existing routing system, and not relying on centralized server and so on. Okay, next slide, please. List two discussion. The first discussion is the UDP or TCP, which one we want to select. Here is at least three main requirements. For one is the event-driven, and second is the low resource consumption and the low reliability requirements. This is three, I think, is the mainly the requirements for the PEP. And discussion two is there are two possible options to implement the PEP. Option one is PEP is developed independently as a protocol, and option two is PEP reuse the existing protocol grasp. And on the next topic is grasp. We can discuss together about this question. Is the question okay? Next, at least the grasp and the PEP, the two protocol in here, give the simple compare. The main information is scalability and reliability, like here. I think the grasp is the high resource consumption and persistent connection, and the PEP is flexible connection and low resource consumption, like this. Okay, next slide, please. So next step is to discuss with Anima. Okay, thank you.
Any questions?
Ji Jiang, do you have a question?
So first question is like, how do we guarantee there's a end-to-end IP path to run this protocol? The second question is like, so when we think about like performance and so like, comparing UDP or TCP, so like, do we ever consider the SCTP, which has the benefit for both?
Okay, well, I'll let Robin respond.
I have this reply, simply reply. The first one, I think the guarantee the end-to-end, because this is depend on this the configuration. Because at the beginning, because if we want to send this exchange in the information, so that's either need some this the pre-configuration. So this is the first one, and also this is the reachability is depending on this the forwarding table. The second one, I think that's the second one. I think we to be honest, just now we just think about this the UDP and TCP. You propose this the new protocol. We will have more research on it, and also that's is to check if it's okay for this scenario. Okay.
Okay, thanks.
Randy?
I like the separation. I think it's architecturally reasonable. The MD5, probably you want to pick something from this millennium. That's enough.
Oh, hello, Randy. I maybe not catch all your point. You mentioned that's the security that is depending on the MD5 is okay. is enough?
No, it's not. MD5 is dead.
Use a more modern hash.
Okay. Okay. We can take that into account. Yeah, but here this is just because this is just assume that the PAP is can be developed as a new protocol. But here is just the propose possible mechanism. Yeah, but I think that's more options can be taken into account.
If we have no more questions, we'll move on. I would really advise authors to articulate who is the end consumer of this data, because networking devices don't usually do anything with this kind of information. So if the end consumer of the data is kind of NMS, the real question would be why not use south-north communication? We already have highly optimized channels such as gRPC, and I would really like to see better justification of doing it horizontally rather than vertically. And hopefully on the list.
Jeff, thanks for your comments. I think that's you. In fact, in the previous page, we talk about this, the reason to introduce the West-East, the network monitoring. And also, I agree this one. And also, that's we think this protocol should light protocol. Yeah, but I think that is the possible effect on the existing operation of routing protocols should be taken into account.
Thank you.
Jeff, back to the discussion in IDR of every protocol has to have a mechanism like X. Instead, this abstracts the mechanism. So that's what I meant when I said I kind of like it architecturally.
Point taken. Tarlis.
Hi, are you bringing up the slides to share, or should I?
Yeah, I am. Thanks.
Okay, so yeah, so after seeing PAP and we started seeing that on the Anima mailing list, I thought I'd kind of debrief RTG working group on the work we've done for GRASP, which I think is already providing everything and more that PAP is trying to do, and that's going to be pretty soon a standard RFC. It's in the editor queue. Next slide. Sorry, yeah. Right, so just a quick rant in the beginning, right? So I mean, so self-optimizing, self-healing, is something that really, our ancestors with the ARPANET introduced, right, through the distributed routing protocols. So it was really great, but then really, it went downhill from there. We started to evolve, through SDN into more of, a revival of SS7 with the hierarchically centralized management. And obviously we know a lot of reason why that's necessary, but we've seen how in parallel in the 80s through the 2000s, others have taken on the step of building more, self-automating, self-management, optimizing networks like, AppleTalk, and then also IBM and others started the autonomous networking. So we basically in IRTF and NMRG started to revive that self-automation, and then started to standardize the building blocks for that in the Anima working group, and GRASP is one of the key building blocks of that. And so I wanted to try to summarize maybe from a pragmatic perspective how it could be really quickly be introduced into running networks without necessarily having to use all the components that we're standardizing in Anima. Next slide. So, routers of many vendors had scripting support for automation, often since the 2000s, right? So the first language probably was Tcl. I've seen that in many vendor routers. Now there are many more languages, and that stuff has been widely used even before the advent of SDN to provide device local automation, in which a script uses router internal CLI, and now hopefully also Yang interfaces locally to poll and monitor some router behavior and trigger actions. And I could go on for a lot of interesting examples what's been done. Maybe in general, scripting, it's something that can run on the router itself, can be built not only by the vendor but also by the customer, and can have its own life cycle independent of the router OS, right? So that's basically what we have. But so what's the next step? Next slide. So how do you do across the LAN between adjacent routers, or even across the whole network, east-west automation in a coordinated fashion? In Anima, this is what we're calling autonomic service agents, right? So, and the examples from which we really started a lot of Anima work were pain points of automating security, right? So, for example, many routing protocols have kind of symmetric key options, and there are no automated key negotiation mechanisms, and those are really very easy to do when you can discover a peer and have a simple negotiation with a neighbor to set up a symmetric key, and then you configure your routing protocols into that. And even if the routing protocol doesn't have such security, you can always configure IPsec, an appropriate security association IPsec below it, like in PIM or other routing protocols that don't have that. And you can go beyond routing protocols for self-automation when you can communicate east-west with your peers, right? So MACsec, a lot of interesting non-security automation. Obviously, my examples would come from multicast or QoS, but I very much liked the examples given in PEP, right? So those would be ideal ASAs in Anima, if they would be specified out in terms of what's the actual negotiation that would need to happen to make BGP or other routing protocols operationally work better. But when you look into this, how do you build these things? And before we did Anima, we experimented around this in one-off fashions. Communication is very hard to script and repeatedly requires components that are common across all these automation use cases. Next slide. So what are those, right? So the first requirement is really security, right? So you need some mutual keying material to authenticate the peers, and also for confidentiality, for communication between them, because as soon as you're starting to automate these things, you're really taking the control point of the human out of the picture that is using north-south communication to basically set up the coordinated behavior, right? So security for anything that goes east-west between the nodes to automate other things is really very important. And you really want to have a common, easily extensible negotiation protocol, right? And peer discovery mechanisms, link local and network-wide. And when you then want to do network-wide discovery of candidate peers to automate with, you also would like to have routing protocol independent layer 3 reachability, because one of the things you may want to do is really even start configuring the routing protocol, not only securing it. Next slide. So let's assume, and I'll get back to that in a later slide, the precondition for, the secure peer-to-peer communications there. We've got the discovery, and we've got the mutual trusted keying material. So then obviously we've got the building blocks like TLS, or if you can survive packet loss, DTLS, right? So that's authenticated confidential communication. So we don't need to invent anything new in there, right? So then comes the question, so what else do we need for a common, east-west communication protocols? And in Anima, we looked into the building blocks that have been successful in the web layer, and that was basically, a data modeling language that was embodied in the programming languages like JSON in JavaScript. That's basically making a lot of communication negotiation very easy in the web layer. And then, a few simple primitives where, in the application layer, web layer, it's REST through HTTP and URIs. And so those two building blocks we try to emulate. Next slide. In a more efficient fashion. for east-west communication between potentially even constrained devices like low-end routers, IoT devices, and so on. So what we used was what at that point in time, a few years back when we started GRASP, was just upcoming and now obviously has gained a lot of attraction through the IETF, which is CBOR, which is a binary encoding of pretty much the same data structures that JSON has. It does not only support textual, but also much more compact binary data. So it's an ideal evolution from all the binary protocols we love to build, but without the ASCII art, but actual schema languages like CDDL to have formal definition of then the negotiation message that you're forming. And obviously we didn't need to have the whole overhead of HTTP or so to build something like REST, but we of course, for the few primitives that GRASP offers, are simply using CBOR message headers as well, right? So basically GRASP is a very simple exercise in CBOR where 99% are what each of the automation application would do, and GRASP itself providing simple primitives, and then obviously the registries that we're building with IANA. Next slide. So just as a simple example here, just a simple message exchange from initiator to responder. So I don't want to delve too much into the details here for time reasons, but X2, for example, would be the IANA registered application, kind of a particular automation application where the initiator requests that, and then, for example, the responder would respond with some value of that, a string and a numeric value, and all of that is shown here in CBOR. The schema would be defined in CDDL, and that would be simple binary messages, pretty much as efficient as any of the existing binary protocols we build in the routing area in the IETF. Next slide. So how we can discover GRASP peers for setting up this automation. Obviously, if we have simple things where a routing protocol like in BGP may already have a configured peer, we can latch onto that, but GRASP itself comes with its own discovery mechanism. So we've got layer 2 GRASP multicast to announce or request objectives. That's currently specified and standardized on top of IPv6 link local multicast. And we can also do a whole network domain-wide multicast announcement or request objective like looking for services. And that doesn't require any layer 3 connectivity, unicast or multicast. Instead, it's a simple GRASP per hop forwarding and flooding agent that creates loopless flooding by per unique message identifier. So that's a very simple thing that could be added in a domain to all routers to enable self-automation. And that adds to primitives, flood and discover to the GRASP primitives. Next slide. So, and this is basically the step-by-step, what's the most simple way on how you can start with GRASP all the way up to the full Anima option, right? So the most simple thing, of course, is you just require, LAN discovery. So you just use a GRASP layer 2 multicast. You may already have some TLS keying material. And then basically GRASP is a very simple standalone thing without anything to be added. And that would be already, a superset of what PAP promises to do, right? So now we want to do layer 3 wide discovery. So then you would need to add that this discovery agent that is forwarding the messages across layer 3. So you could auto-configure then your IGP across the domain with an appropriate GRASP application. We also have the autonomic control plane, which is also a self-built hop-by-hop virtual out-of-band management, like a automatically built VRF. And that basically would allow to build all that and also have layer 3 unicast connectivity to remote peers before you have any form of layer 3 unicast routing otherwise. And finally, there is obviously an automated way to create your mutually trusted keying material. We call that Brewski, and that of course is also self-configuring with the help of the ACP. 2,400 lines of code. Test suite, includes various ASA examples on how to basically, build this self-automation and documentation. Next slide. So we really think that GRASP is ready to use, and would be lovely if people interested in automation, east-west communication, like the use cases outlined in the PAP document, would, for example, concentrate on refining those in a way that they can actually build as application of GRASP, right? So I mean, there is no need to reinvent that common communication protocol. We're hopefully using the best, common knowledge of the IETF, CBORD, TLS, the keying material, right? So that would be happy to do in conjunction between whoever is the experts on the use cases, like routing protocol automation, routing working group, and Anima to help with the formatting everything. And, yeah, we'd really love to evolve, our networks into something that's self-automating and doesn't always require the big SDN controller called MUM to do any form of automation. And I think that's it.
Yeah, why don't you, well, should we get questions from G first?
Mm-hmm.
I think G was in the queue first. G?
Go.
We cannot hear you, G. Please try to.
Clean the queue, so just drop.
Oh, I think G said maybe that he was in the queue accidentally. So we'll just go ahead with Robin.
Robin from Huawei. Torres, thanks very much for the information. I think this is valuable for our reference to design the PAP. And here, this because that we propose this the discussion, and in the PAP presentation, because I according to my understanding, is GRASP is based on the TCP. So I'm a little about the resource assumption, because that if the PAP is used to locate the error of the BGP, so maybe we have to set up the full mesh the TCP peers with the full mesh the peers. So I think that's maybe a challenge work for the PAP, because the BGP full mesh already proposed a challenge for the operation. But if for the PAP is only for the network monitoring, so that is also to set up the full mesh TCP based peer. So maybe that is a little concerned. That's my point on this one.
So GRASP itself doesn't really specify the underlying transport. So we've basically outsourced that to a component we call the security and transport underlay for GRASP, right? We define GRASP messages, and those can be, put into TLS. They can be put into DTLS. They can be put into QUIC. They can be put into any, secure underlying transport protocol you want. And then they can be nicely standardized in the IETF. Of course, you can also try to simply put GRASP messages inside of UDP or TCP or anything insecure, and you can make it perfectly well work in your network. You'll probably just have problems getting through the security area review in the IETF to get it standardized. And that isn't a GRASP problem. That is something that is IETF expectation that would apply, I think, equally to any protocol. Like if you reinvented GRASP and called it PAP, I think the same type of, transport considerations in the IETF would apply.
So Robin, did you want to respond or?
Oh, okay.
Okay, well, at this point, let's go with Brian then. Whoops.
Yeah, hi. So the prototype code that Thomas mentioned is my code, and I should say that it's full of disclaimers saying this is not yet ready for production use, but you know that's a problem that could be solved probably. What I wanted to comment on is I looked. It runs over TCP or TLS at the moment, mainly TCP, but I looked at what would be involved in switching to UDP. The messages, of course, could perfectly well be wrapped up in UDP packets and sent, but my impression was that all the overhead that TCP allegedly adds, I would have to add back into my code just to make sure that UDP messages were delivered to the right recipient, to the right session, the right thread in a threaded implementation. And you would also have to put in more recovery logic because UDP doesn't do that for you. So I'm not at all convinced that there's an efficiency argument against using a transport layer. That's all I wanted to say.
Yeah. And I think, you know, through the years in Anima, we've seen a lot of opinions about transport layers. So I think that the prudent thing is obviously to define the message protocol independent of the transport and the security, as we've done in GRASP, and then basically let the chips of the IETF call whatever the wisdom is. So I think if we had, for example, more IoT people in here, they would come and say that, you know, some even lower overhead things based on UDP is really crucial in very low-end devices. You know, that's why they did CoAP to avoid TCP, and that's based on UDP. So I don't think there is, you know, a industry-wide common understanding of what the best transport is, and that's why we did GRASP the way we did it.
Jimin from Huawei. Hello. Okay. So I'm not the actual comments. I just thanks very much for the tourists and the company's clarification of the transport usage for the Anima. So we will go on to check this information and also to go on to thinking about the design using the GRASP for the PAP.
Yeah. I mean, as I said, I would really love if you folks would think about, you know, refining and building and proposing drafts for the actual examples you gave in terms of BGP, and I forgot the other one in terms of, you know, what automation it is you want to do, right? Within Anima, obviously, you saw the slide on the securing protocol. So if I had more cycles, and some other folks would love to basically build those ASAs, there are couple of ASA examples that Brian said are in code. We're also having some ASA with negotiation coming into RFCs. So I think we're starting to build this framework of the self-automation thing. So would really invite anybody from the routing working group interested in that automation to see what they are interested to contribute, and they wouldn't need to worry about the encoding crap, which we could happily take care of.
Okay, happy to do.
Mm-hmm.
Yeah, thanks a lot. I mean, this does seem like a pretty good way to bootstrap the sort of the use cases, and you know, we could spend a year or two discussing encodings for PAP, but instead, you know, it makes sense to try these use cases in the existing encoding. You know, see. It seems like you would get a lot of benefit from a reliable transport to begin with. You wouldn't have to worry about a lot of protocol stuff if you could just be sure that messages were getting received. So you know, that would be I think a pretty good way to get this well, bootstrapped, as I said, or moving along faster with solid, more convincing use cases.
I'm trying to remember, there was this one effort to try to unify it and build better, you know, common security for the different routing protocols, and I think that ended in pretty much nothing. So, you know, if people also think that the securing of the routing protocol is still something that the industry struggles with, I haven't followed track with that. Beside the other operational examples given in the PEP draft, right? I think the securing might be something that could be most easily done upfront.
Do you have a comment, Jeff Haas? Go ahead, Jeff.
I just wanted to read that Edward V. thanks Starless for great presentation.
Thanks.
Thanks so much, Starless. Great presentation, and looking forward to more cooperation in this area. So we are continuing with Olivier.
Thank you. Do you hear me?
Yes.
Yes.
Okay, so this is a presentation of work in progress, which is a paper that was published a few weeks ago. This is joint work with Thomas Wirtjen, Quentin de Koning, Randy Bush, Laurent Van Bever, and myself. Next slide. So if we look at the evolution of the routing protocols, it's clear that they evolve, they evolve regularly, and they need to address new requirements. And as an example, I looked at what's happening in the RFCs that we have published for BGP, PIM, and OSPF during the last 2 decades, and I just counted the number of must and should that occur in our RFCs, and we see that the complexity of the protocol increases over time. And then the question is, what do we do as a community to tackle this increase in complexity and this extensibility of the protocol? Next slide. So if we look at the evolution and the standardization within the IETF, and this is an example that we looked at the IDR working group, and we tried to understand what's the delay between the first idea about a new extension to BGP and the publication of the RFC. And on the figure, you show that the standardization delay for some RFCs takes up to 10 years, and the median delay is about 3.5 years. So every time we have a new ID that needs to get into BGP, we discuss about it for several years before it gets implemented and before it gets deployed. Next slide. And as a solution, what do we do when we want to deploy extensions? Basically, we have networks with multiple vendors, and each vendor has its own configuration command. And so as an operator, we need to tackle this diversity in configuration commands. And the solution to that is to go with netconf and YANG, but this works only for features that are configured inside the network. Next slide. And we've seen over the last years many examples, such as this one from Robert and others, asking new BGP options and new BGP extensions that have been discussed for several years. And in this example, the document was requesting a new BGP attribute that would allow to encode geolocation and other types of information. Eventually, it was not accepted by the working group, and it was never standardized and implemented. But there are use cases and there are operators, maybe small ones, that would like to have these kind of features, and they cannot have these kind of features because they have not been standardized within the IETF, and they have not been adopted by everyone. Next slide. So the question that we ask ourselves in this paper is that, is there a better way to organize BGP implementation and routing implementation in general so that we can address this extensibility and the flexibility which is required by network operators? And we propose XBGP as a paradigm shift for BGP implementation, but the idea is applied to other routing protocols as well. Next slide. So what we propose is that each XBGP router would expose a simple API that allows to dynamically extend the protocol with platform-independent code that we call plugins. And these plugins can be developed by network vendors, but also by network operators. so that they can extend the features of the BGP protocol that are used inside our network by downloading extension code directly on the routers. And the solution that we propose is that to have a vendor-independent API that allows to run these extensions on different vendors, on routers from different vendors. Next slide. So different routers expose the same API, and you could consider a routing protocol implementation as a kind of microkernel that exposes a set of system calls. And by using these system calls, you can extend the routing protocol. And we have done that with BGP. And let me explain you briefly how we did that with BGP and how the solution works. So next slide. So if you look at the BGP specification, in the BGP specification, there is no API that every BGP implementation should implement. But if you go more deeply in the RFC 4271, you can see that the processing of the BGP messages follows a workflow that all BGP implementation needs to apply. So typically what happens is that when you receive a BGP message from your peer on the left, it first goes to the import filters, and you have an attribute that needs to be maintained by the router. Then the routes that are accepted by the import filters will be placed in the lock rib. And then the lock rib is a data structure that contains all the acceptable routes. It runs through the BGP decision process that selects the best route towards each prefix. Then the best route are downloaded in the FIB. And then we use the export filter to send new messages to the peer. So by looking at that, by looking at this workflow, we can identify, next slide please, several places inside the implementation that are shown with the green circles, where you do special processing on the BGP messages, and these are the key locations of any BGP implementation that you could want to modify if you wanted to implement new stuff in a BGP implementation. Next slide. So let's look at an example, and coming back to Robert Razuk geolocation attribute. So this is basically a BGP attribute that allows to encode the geographical coordinates of the routers where you have learned an external BGP route, and then you distribute that inside your AS. So if I want to add this attribute to a BGP implementation, and I want to implement that using a plugin, so that code that can be downloaded on the router, what do I need to do? I need to be able to decode the geolocation attribute. I need to be able to compute in the decision process, for example, the geographical distance between the route that I've received and multiple routes that I've received with the geolocation attribute. And then I need to be able to send the geolocation attribute to my peers over iBGP sessions. How do I do that? Next slide, please. So I will inject these different code inside the BGP implementation at the location. So the decoding will be part of the code that receives BGP message from the peer. The locating the nearest router will be part of the BGP decision process, and the serialization will be part of the code that sends messages to the peer. Now the question is, how can I execute code that comes from the network operator on routers from multiple vendors? And next slide, please. So the solution that we use is that so we add libxBGP, which allows to connect to data structures in the routers and extract additional information from the routers, such as the configuration file. Next slide. So now to execute the plugin, what do we do is that we reuse eBPF. So eBPF is a virtual machine that is part of the Linux kernel. And this virtual machine allows you to execute platform-independent code inside the Linux kernel with some security properties. And what we have done is that we have added these eBPF virtual machines at the 5 insertion points that are shown in the slide, so that they can execute code that implements the BGP extension. So in our case, the 3 blocks of code to decode the geolocation attribute, to locate the nearest router, and to serialize the geolocation attribute to be able to send it to the next peer. Next slide. So what have we done? We have added this feature to different BGP implementation. Let me show you on the next slide how it works. and what's the cost of doing that. So we have adapted this approach, so the XBGP approach, to two open source BGP implementation that are Bird and FR routing. So basically, we had to do small changes to the code base of these two implementations. We have changes a few tens of lines to implement the 5 insertion points that I've mentioned. We have developed a plugin API that allows to libxbgp to extract information from the host, such as the neighbor table and things like that. And then we added an existing eBPF virtual machine and libxbgp. So with a few hundreds or a few thousand lines of code, you have two very different BGP implementation that expose the same API and which can run the same plugins and the same extensible code. Next slide. So to demonstrate the feasibility of the approach, we have re-implemented route reflectors, so the cluster, the different attributes that are used to do route reflection, and this costed us about 300 lines of code. We have added new filters to do route origin validation to support valet-free path check in data centers, and we have implemented the geolocation attribute. And there are additional information in the paper, and there is running code. Next slide. So to summarize, with XBGP, you can think of your BGP implementation and more generally of your routing protocol implementation as a kind of microkernel operating system that exposes an API which allows network operators and researchers to run code that allows to extend the protocol itself. So there are more information in the paper. There is running code. And we would be interested in discussing with network operators and other BGP implementers to discuss the approach and to see how the approach can be improved and can extend to other routing protocols. Thank you.
Jeff, your mic.
Hopefully you can hear me this time.
Yes.
Thank you. So Olivier, thank you for the presentation. So I think the nice thing that is an output of this presentation is that yes, plugins can be done for allowing code to be hooked externally. You know, the Linux kernel is an excellent example of that. The challenge, I think, that's not really covered in the paper, or at least the presentation here of the paper, is most of the headache for BGP is really incremental deployment issues. So writing code isn't all that bad. Getting code that can run in implementations that are scattered around the internet and follow BGP rules in terms of validation and such, that's the main challenge. So I agree that having plugin frameworks is actually a very useful thing, but I think that's not necessarily the hard problem here.
But I think there are benefits in being able to deploy extension inside an AS, so for iBGP only. So doing it over external BGP is much more difficult. But for iBGP, I think it makes sense, and it could address some use cases for network operators that have specific requirements. And it could also allow network operators or network designers to develop new extensions before they are being discussed within the IETF. And so you could get information, you could get prototype running code that could be discussed within the IETF without having to change complex implementations and to do a full implementation.
I understood. I'll leave my comments with, I agree with you that doing this is not hard, and that if you contain, as I would call it, the blast radius of this problem to something that's strictly internal, you're right that this is not too much of a problem. But the blast radius is really the discussion that's the difficult one for incremental deployment. It's very common for features in development to have unfortunate side effects far away from where they're at. I will cite the attribute 128 issue that many people are familiar with as an example of a feature that had two different versions that caused large network outages. My suggestion is perhaps part of the conversation, if you're going to talk at least about BGP, is whether or not BGP should be basically leveraged into a side protocol for different purposes to separate the inter-domain case from the local case. That's it. Thank you.
Thanks.
Hi, Jared Mach, Akamai. So I think this is interesting, but I have a lot of concerns here, specifically around deployability and usability and testing. So if we were to do this, similar to what Jeff was talking about with the attribute 128 issue, of which I'm still trying to get the config out of our many of our network devices for, because we have a variety of code bases that we still run. I'm concerned about what happens when we deploy these plugins and they have different, different results across different vendors, and how that kind of bug ecosystem interacts. Because it's one thing to specify a protocol and a method for transporting, this metacode, but it's a whole nother thing to discuss what that operational impact is. And I think similar to what Jeff commented about the internal use cases versus external use cases, we have a lot of internal use cases where we transport BGP data and signal that around our internal infrastructure. And those use cases tend to not really align with what shows up in the public internet. And a lot of what happens is people have maybe more fine-grained signaling that they want to do for geolocation than what you actually want to announce in the routing table as a result. So I'm very concerned about something like this and what happens in the operational use case when we have a lot better things, like if we want to signal, geofeed data or something. There's the geofeeds RFC that was recently published, and there was discussion last week at the IEPG meeting about how to actually go and potentially authenticate and sign that data to provide more granular information than what you actually want to publicly expose in BGP. So there's definitely an interesting idea, but I really fear the unintended side effects that this is going to introduce and instability that it'll create as a result.
Yes, so I think there are two different parts of the presentation, and there are two different elements. So the first one is the ability to consider a routing protocol as let's say, a kind of microkernel operating system that exposes an API and that allows you to extend it. And this is generic, and although we implemented in BGP because it was easy for us to extend BGP and to do tests with BGP, we believe that it can apply to any routing protocol, and that's why we discussed with Jeff to present that here, because this is an idea that is generic and that would be applicable to any routing protocol. I agree with you that doing that over external BGP session and over the public internet is something that would be between brackets dangerous, and that would need to take much more care to be able to do that. So this is a research prototype which is intended to show that you can extend routing protocols and you can view the routing protocol as a different way. And for the BGP extensions and for the BGP use case, we are focused on internal BGP issues. We don't consider external BGP as a possible solution right now.
Yeah, I love this this view and way of taking up the definition of route manipulation. quite obviously, when you provide agile development for complex systems, you introduce some fragility, and you need to control very carefully. And that's where I certainly see Jeff's point. However, I note that what we have now, usually in industrial production, is a system where we actually already have some control points where user specifications are done by the operators. And in the BGP case, that's quite clear that the policy definitions that are available to the operators. And my previous work on defining policies and compiling that down to policy configuration code quite certainly did show me that evolving the definitions of the policies in a running network is something that exactly points to the control problem that Jeff was mentioning. However, I would say, and by the way, the use of that kind of stuff, which to a large extent goes into the use of communities, is to a very large extent used on the global eBGP thing. So kind of I see an opening with your approach to actually allow users to do much nicer and much better controlled stuff for extending functionality and customizing functionality far beyond what has been done so far with the policy languages. Certainly, with great power comes great responsibility. And yes, it should not be abused. Abuse will happen nevertheless. But the agility that comes out of a proposal like this, I think, is pretty much needed. Thanks.
Yeah, so maybe let me try to answer a bit some of your concerns. So you mentioned that operators do a lot with BGP communities to implement the policies, and basically the BGP communities is an ad hoc solution. So you have to play with route filters, with access control lists, with route maps and stuff like that to be able to implement the policies that operators want. On the other side, by using XBGP, what you have is that you have a standard programming language. In our prototype, this is C, but this could be another language. And when you have standard programming language, it's also possible to use software validation techniques where you can specify the properties that a plugin has to be able to support to be acceptable by a router. So obviously, we don't want a plugin that runs forever, but we can have properties that are defined formally, and we can design tools based on the progress in software verification that will verify that the plugin is working, is behaving correctly according to the properties of the underlying BGP. So that's something that you can do if you have a much more expressive language than the access list roadmaps that we have today. And we can leverage lots of advances in software verification during the last years to verify that.
Thanks, Olivia. Edward, yours last one. Please be quick. We are ready on time. Yeah.
Thanks for good presentation. I have one concern which potentially possible to mitigate. Feature velocity by itself is good. Yeah, it's a good feature. Yeah. But unfortunately, for majority of telco worldwide, multi-vendor interoperability is more important. Unfortunately, the feature velocity could not be trade-off to instead of multi-vendor interoperability. What I see here as a risk for multi-vendor interoperability is the API. The API should be exactly the same for all implementations of all vendors. On the previous slide, I have seen that for the current implementation, in one case you have 400 API calls, in another case 600 API calls. It's already a big alarm for me. Big alarm because it looks like you do not have mature, stable API, which you could really demand from all vendors. And it means that there would be no multi-vendor interoperability. And if would be no multi-vendor interoperability, I believe this particular good effort will not be accepted by the market. Therefore, from my point of view, you could mitigate multi-vendor interoperability problem if you will clearly specify and make it mandatory some basic feature, basic API calls. I don't know how many, 400, 600, it's up to you to decide. But it should be very rigid specification for API, which should be really mandatory. Then multi-vendor interoperability would be not lost, and then it's potentially would be possible to progress with this effort.
Yes, so just to answer your comments. So we have a very simple API, which is available on the website that I can provide. The slide that Jeff shows here shows the number of lines of code that we have to change to FR routing and to BIRD to be able to implement the API. So this is not the number of calls in the API. So we have a few tens, about 10 different functions in the API. So the API is very simple. And the slide shows only the number of lines of code that we had to change in the BGP implementation to be able to support the API, which means that, in fact, the API was already part of the FR routing and BIRD implementation, and we did not have to change that much to be able to support the abstract API that I mentioned earlier with the workflow.
Okay, fine.
Olivia, thank you so much for coming over and sharing your work. It's always exciting.
Thanks for the invitation.
I'm looking forward to hosting you anytime. We've been working together probably 10 plus years, so it's great. Thank you everyone for joining us tonight or this morning, and we will see you virtually again in 4 months. Take care, stay safe, and see you soon.
Thanks a lot.